Hi, thanks for checking out our paper, Accounting for Sycophancy in Language Model Uncertainty Estimation. This is a joint work with my collaborators, Mert Enan and Malihe Alikani at Northeastern University, and I'm Anthony Cecilia. So this paper is about language models, and while I think probably these systems need no introduction, it's still really amazing to see how widely used they are. For instance, OpenAI is reporting hundreds of millions of monthly active users, and they're just one, provider that we see at the top of the App Store. But, despite this wide adoption, these systems, still show plenty of pitfalls that can really make them rather ineffective collaborators when we use them to solve problems. So, a really simple example of this, we can, think about asking a model a simple mathematical question. And as expected, in sort of the default settings, the model is going to get these types of questions correct. The one I'm showing on the screen is obviously very simple, right? Um, and so the problem kind of arises when users try to collaborate with models in order to solve similar problems, right? The story changes here when users do something simple like provide a suggestion. So in fact, models really can even change their answers to better align with these user suggestions, even when these opinions are factually incorrect. And this is a bit of an older example, but there's plenty of work uh, in recent years showing that models still tend to do this type of behavior, right? So this behavior is known as AI sycophancy, and it really poses a big problem for collaboration because it makes trusting an AI system rather difficult when we're providing some suggestions or other input to the problem that we're trying to solve. So the point of this paper is really to understand whether expressing confidence about opinions on both the side of the user and the model can help us to prevent and detect this behavior that we call sycophancy. Well, we looked at a few other data sets in the paper. Today, what we're going to do is focus on a benchmark that we proposed at ACL 2024 called Fortune Dial. And so this data set consists of about 8 different conversation corpora. They range from different sources across the web, covering diverse topics like ethics, social issues, and negotiation. And the corpus is really specifically designed to measure uncertainty in conversational settings by looking at a task called conversation forecasting. And so for conversation forecasting, the input of the task is a conversation, and the output is typically a prediction of some future or otherwise unseen event. So, for instance, the input could be a negotiation between two parties about maybe some exchange of goods. And the prediction here that we'd be making would be about whether, a deal occurs or some other property of the deal, what type of deal occurs, right? Um, and this would be, at some future point in time, not present in the conversation. So this is what conversation forecasting is. There's lots of other examples too. Legal decisions, for instance, we could look at the conversation in a court and try to predict what the court's eventual ruling will be. Okay, so we can kind of get into results already. I've shown an example on the left of the type of task we're talking about. Again, just for reference. And what we want to do first is really just establish some baseline results on this data. We can look and see how model accuracy changes, specifically as a function of different types of user suggestions. So on the vertical axis, what we'll be doing is showing model accuracy. On the horizontal axis, we'll be changing the percent of times that a user suggestion is correct. And so what we see when we actually look at the results here is we see the sycophancy problem we mentioned before. In red, we have the baseline accuracy. This is without any sort of user suggestions, and it shows that models get just under 60% accuracy on this task. And so, like we mentioned, forecasting is a fairly uncertain task to begin with. In blue, we have the model performance with user suggestions, and so we vary the user correctness here. And so when users are frequently incorrect, the model performance suffers too, dropping well below chance. And this is really what we mean by sycophancy, right? Where we would have preferred that the model sort of hold or maintain its original correct opinions, what we see is how the model fails to challenge the user errors here and instead reinforces them. As we mentioned before, what our proposed solution is really to look at confidence estimation. So here we'll be looking at model accuracy again, but we'll be splitting by model confidence. And so we're asking the model to report its confidence. We're also asking the user to report their confidence, but we'll look at that a little bit later. We group on the horizontal axis here by the model's confidence estimates into a low and a high category. And all user suggestions here will be incorrect. So that's an important detail. So as we can see, model confidence is a fairly good indicator of accuracy. When models have low confidence, they're generally less correct. And when models have high confidence, they're generally more correct. And so this is a fairly general insight. It's been shown before, right? Models tend to have fairly accurate signals of their confidence. But the key thing to remember here is that the users are still providing incorrect suggestions in all of these instances. So what we're demonstrating here for the first time is that models' confidence estimates are fairly robust to this issue of sycophancy bias, right? They're still accurate even when users make suggestions, which means users can trust confidence estimates even when they make suggestions. Now we can also look at the flip side of the coin. And so this is focusing on user confidence. And what we're interested in is whether models understand confidence in user suggestions. So again, we set all the user suggestions to be incorrect here, but what we do is we vary the user confidence. So what we see is that model accuracy is higher when users express low confidence and lower when users express high confidence. And so this is a good sign, right? It means that the models are able to accurately interpret user signals of confidence. So, they're less likely to exhibit these sycophantic behaviors that we were worried about when users express that they aren't very confident, for instance. Okay. The last thing that I wanted to talk about was just some of the methodological contributions of this paper, and there will be a lot more details in the paper itself. But one of the common ways to actually improve confidence estimation in previous literature is Platt scaling. And so I've shown the basic equation here, but basically the way to interpret this is that we learn some sort of generalized linear model that we can use to rescale the estimates or sort of calibrate them to what the ground truth is. What we do in the paper is we take this insight that we had in some of our previous work. For instance, some of this was published at ACL 2022. And basically what this work shows is that this type of generalized linear model, this type of prediction using a linear model can suffer from bias as you sort of shift data. And effectively, that's what's happening when users exhibit different behaviors, right? We're having different shifts in the data. And so when users exhibit a behavior like providing a suggestion, this is a shift in the data that we want to try to represent. So the simple kind of explanation here of what we're doing is we're learning a separate linear model or a separate calibration function for each of the different user behaviors, and this can then make the model more robust to these behaviors. And so in practice, that's what we see. Looking at some empirical results quickly, we see how our method further improves the confidence estimates when users provide suggestions. And so the metric here that we're looking at is called explained variance. Sometimes this is called Breyer's skill score as well. And it's just really trying to measure how much variation in model accuracy we can explain by using the confidence estimates. And so we can see in red, our method far outperforms the baseline linear model for a variety of different user populations. Okay. So just to recap, we discussed a couple of things today. The first thing is sycophancy. Models are biased towards this sort of uncritical agreement with users, and this can prevent effective collaborations. Meanwhile, if users and models can signal their uncertainty, this would seem to have a particularly effective benefit, right? Because the models are able to understand and express uncertainty. And all of this is robust to this issue of sycophancy, right? So for instance, users are still able to trust uncertainty estimates even when they're providing suggestions. Users can also suggest that they're unconfident, and models can accurately interpret this as well. And so the last thing that we proposed here was just some techniques to improve these uncertainty estimates even further, especially in the presence of different user behaviors like user suggestions. And so that's everything I wanted to talk about. Thanks very much for listening. I've posted a GitHub link here, and there's also plenty of additional details in the paper if you're interested. Thanks.